Hello everyone. In this video, we will learn about the factorial notations. What is factorial? What is its application? Actually, factorial we have to apply in calculations of permutations and combinations, and also in the chapter of probability where we have to apply permutations and combinations. So, what is factorial? Let's learn that first of all. A factorial we can represent by factorial n, or we can write this as factorial n or n factorial. So we say factorial n or n factorial is the continued product of first n natural numbers. It means what? It means we can say that factorial n, or we say factorial n is equal to 1 into 2 into 3 into 4 into so on up to n, the product of first natural numbers. We can also write this as n into n minus 1 into n minus 2 into so on up to 3 into 2 into 1. It means we can also say that in case we want to calculate factorial n or n factorial, we can multiply all the numbers in the reducing order up to 1. It means in case we want to find out the value of factorial 3, that will be equal to 3 into 2 into 1, that is equal to 6. Here we have to remember one more thing. Please note that factorial 0 or 0 factorial is equal to 1 always. Why it is so? We will be learning in the next videos when we learn about the permutations. At that time, we'll prove it. Why factorial 0 is equal to 1. Suppose we want to calculate the value of factorial 8 upon factorial 4. We can write the value of factorial 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Upon factorial 4, that is 4 into 3 into 2 into 1. And we find that these are cancelled. So the product we are getting is 8 into 7 into 6 into 5. This is equal to 1680. Can we make it a bit easy? We can also write this as factorial 8 upon factorial 4 is equal to 8 into 7 into 6 into 5, and is it same as factorial 4 or not? And here also it is factorial 4. So this factorial 4 and factorial 4 cancel, and again the answer comes as 1680. Why it is so? Let's learn that. So we were understanding why we have written factorial 8 as 8 into 7 into 6 into 5 into factorial 4. See here we know that n factorial or factorial n is n into n minus 1 into n minus 2 into n minus 3 into so on up to 3 into 2 into 1. If we take this particular n separate other than these two all the factors, will it be n minus 1 into n minus 2 into n minus 3 into so on 3 into 2 into 1 or not? And what is this? The continued product from 1 to n minus 1, or we say n minus 1 to 1. Is it factorial n minus 1 or not? So we write this as n into factorial n minus 1. That's the reason. It means in case we want to calculate factorial 6, we can also write this as 6 into factorial 5. It can be reduced by 1 if we are taking 6 out. We can write factorial 9 as 9 into factorial 8. and this was the reason that we could write factorial 8 as 8 into 7 into 6 into 5. These products we've taken here. After 5 it comes as 4. So this becomes factorial 4 in multiplication here. This is an easy way to calculate the values of the factorials or problems on factorial. One more thing I would like to tell you here, like we are writing factorial n as this symbol, exclamatory sign. If we use this in writing ourselves, sometimes I find that the students are getting confused. If we are writing factorial 6 here, they read it as 61 sometimes. So to avoid this type of confusions, generally in writing we use this particular symbol for n factorial or factorial n. Now we will learn the values of some of the factorials without calculations. We can remember them. Of course we can multiply and find the value, but if we remember, we can directly apply that. See here we know factorial 0 is equal to 1. Factorial 1 is 1. Factorial 2 will be 2 into 1, that is equal to 2. Similarly, factorial 3, we can multiply 3 into factorial 2, that is 3 into 2 is equal to 6. It means in case we want to find out the value of the next factorial, we can multiply only that number in the factorial before that. Factorial 4 similarly will be 4 into 6, that is 24. Factorial 5 will be 24 into 5, that is 120. Factorial 6, 120 into 6, that will be 720. Factorial 7, 720 into 7, that is 5040. And factorial 8 is, if we multiply this by 8, that is 40320. Like this, at least we can remember the values up to 8 factorial or factorial 8. Let's take some of the examples now based on the factorials. Before going to some examples, let's learn what is the HCF and the LCM of some of the factorials if we are given. See, suppose we have been given factorial 4 and factorial 6, and we want to find out the HCF of them. HCF will be factorial 4. And the LCM of these two will be equal to factorial 6. It means what? It means in case we have been given some of the numbers in the form of factorials, the highest of them will be the LCM and the least of them will be the HCF, because that contains all the products. So remember that the least of the factorials is the HCF and the largest of the factorials is the LCM. Now suppose we want to calculate some of the values like 1 upon factorial 5 plus 1 upon factorial 7. We have to find out the LCM of the denominators in such case, and here the factorial will be the larger one, that is factorial 7. So if we take the LCM as factorial 7, here we find factorial 5. If we multiply it by 6 and 7, then only it becomes factorial 7. So we find here to be 6 into 7 plus this is 1. So this comes as 42 plus 1 upon factorial 7, or we can write this as 43 upon factorial 7. In case we know the value of factorial 7, that we know is 5040. The value here or the answer is 43 upon 5040. Now understand, suppose we have been given somewhere, find the product of 7 into 8 into 9 into 10 into 11. We want to convert it into the form of factorials. How to convert? We know if we multiply the numbers from 1 to 11, that will convert itself into the factorials. So we multiply it here by the numbers from 1 to 6. That is 1 into 2 into 3 into 4 into 5 into 6, and then 7 into 8 into 9 into 10 into 11. See, now whatever the numbers we have multiplied here, with the same numbers we have to divide here. 1 into 2 into 3 into 4 into 5 into 6. Now we find continued product from 1 to 11. That is factorial 11 or not. And here 1 to 6. That is factorial 6. It means this product 7 into 8 into 9 into 10 into 11 can be converted in as factorial 11 upon factorial 6. Now the next problem we have, find the value of x if factorial x plus 1 is equal to 12 into factorial x minus 1. See here, for the solution of this, what we do? We know that factorial x plus 1 can be converted into factorial x minus 1 if we take it as x plus 1 into x into factorial x minus 1. As we have learnt earlier, this can be written. That is equal to 12 into factorial x minus 1. This factorial x minus 1 and factorial x minus 1 cancel each other. And hence we are getting it as x plus 1 into x is equal to 12. By 12 method we can see this is 4 into 3, the continued product of 4 and 3. Can we say then x is equal to 3 or not? So the value of x we are getting as 3 for this particular problem. This is the answer. The next problem is, if factorial 2n upon factorial 3 into factorial 2n minus 3 and factorial n upon factorial 2 into factorial n minus 2 are in the ratio of 20:3, find the value of n. Solution. We have been given the ratio of these two, means if we divide this by this is equal to 20 upon 3. So we write here factorial 2n upon factorial 3 into factorial 2n minus 3 divided by factorial n upon factorial 2 into factorial n minus 2 is equal to 20 upon 3. We know that factorial 2n can be converted as a product with factorial 2n minus 3 and factorial n into the product form of n minus 2. As we have already learnt, we can write this as 2n into 2n minus 1 into 2n minus 2 into factorial 2n minus 3 divided by factorial 3 into factorial 2n minus 3 divided by what? Factorial n can be written as n into n minus 1 into factorial n minus 2, and this is factorial 2 into factorial n minus 2. That is equal to 20 upon 3. We find here this factorial 2n minus 3 and this cancel, and this factorial n minus 2 and this n minus 2 cancel. Here also we find that this n and this n cancel each other. And now when we simplify this, can we write this as 2 into 2n minus 1 into 2 can be taken from this common, this will be n minus 1 upon this factorial 3 can be written as 3 into factorial 2 or not. This will go in the numerator, so this is factorial 2. This comes in the denominator, this is n minus 1 is equal to 20 by 3. Do we find here that this n minus 1 and this n minus 1 cancel? This factorial 2 and factorial 2 also cancel. And this 3 also cancels this 3. So what we have got here? We are getting here 2 into 2, 4 into 2n minus 1 is equal to 20. This 4 cancels this 5 times. It means we are getting 2n minus 1 is equal to 5. Are we getting from here 2n is equal to 6 over n is equal to 3 or not? It means for this particular problem, we are getting the value of n is 3. The next problem we discuss here is prove that factorial 2n upon factorial n is equal to 2 power n into 1 into 3 into 5, the product up to 2n minus 1. How to prove this? See, when we want to prove it, we can write factorial 2n upon factorial n here, and if we find the product of this factorial 2n, the value is continued product 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 into 2n minus 4 into so on 4 into 3 into 2 into 1. And this is factorial n here. We know if it is 2n, 2n is the even number. The products here will be equally distributed into evens and odds. Equal number of even and equal number of odd numbers we will be having here. So if we take all odd numbers together and even numbers together, do we find here 2n into 2n minus 2 into 2n minus 4 into so on up to 4 into 2 or not? And the odds 2n minus 1 into 2n minus 3 into so on 5 into 3 into 1 divided by factorial n. The products in this particular factorial 2n will be 2n or not? Because factorial 5 has 5 products, factorial 7 has 7 products, factorial 2n also will have 2n products. It means n are these and n are these. If we take 2 common from each of these factors, will that come n times? So it comes as 2 to the power n because 2 we are taking from each. And here we will have n, here it will be n minus 1, it is n minus 2 and so on, this will become 2 and this is 1. Into 2n minus 1, 2n minus 3 into so on 5 into 3 into 1 divided by factorial n. Is it factorial n? Continued product from 1 to n. So this can be written as 2 power n into factorial n into 2n minus 1 into 2n minus 3 into so on up to 5 into 3 into 1 divided by factorial n. This factorial n cancels this. Are we getting here 2 power n into 2n minus 1 into 2n minus 3 into so on 5 into 3 into 1. If we start from here, we can also write this as 2 to the power n into 1 into 3 into 5 up to 2n minus 3 into 2n minus 1. So like this, we could prove this is the right hand side and we started with the left hand side. Hence proved. This is a very important problem based on the factorials. So by discussing some of the problems, you could understand how important is the factorial, what is the meaning of the factorial, where it is to be applied, and how we can find out different calculations based on factorial. In the next video, we will learn about the permutations and their applications in solving some of the problems. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.